Well, hi folks, welcome to Matrix Uploaded. My name is Mark Phillips.
My name is Nelson Ma001.
Absolutely,
Yeah.
brother. Hey, that's a cool name. And what we're going to be doing is we are going to be your maths dudes for this year. And what we're going to do is we're going to start off with number patterns, the most exciting part of the syllabus, I think. And in this lesson, we're going to be looking at a whole lot of juicy, beautiful mathematical number patterns.
Right, guys, we'll start by looking at linear patterns.
Yeah,
simple ones.
Let's have a look.
Let's have a look, guys.
Let's start. Do you want to take them through this, Nelson?
Yeah, let me describe the pattern here, Mark. 11, 18, 25, 32. We're saying 11 is your first term.
Correct.
And it's called A. And the constant difference is when you subtract, say, T2 minus T1 is 7, which is named D.
It's the number that you keep adding on. 11 plus 7 is 18. 18 plus 7 is 25, and so you go on. And as Nelson pointed out, it's the constant difference. It's the second term. Look at the slide. The second term minus the first, or the third term minus the second. 25 minus 18 gives you those. The constant difference is 7.
Right. Now, as Mark has said here, you keep on adding 7, 32, 39, 46. And we say T1, meaning the first term is 11. Another name for A is T1, guys. And T2 is 18, T3 is 25, T4 is 32.
Now the problem comes, though. We've got the first 4 terms.
Okay, what will be T60? Will you know?
Oh, I'd have to expand that thing. It's going to be a nightmare.
Yeah.
So we need a rule, because what if we wanted T a million? That's going to be hectic. So we need a rule. We need a general formula to help us. Let's see what we get, Nelson. Let's derive it.
T1 is 11. Okay, we need to manipulate to get the general rule. T2 is this 11 plus 7. Okay? And we have 11 plus 1, 7, as you see. T3 is you adding 7 onto the previous one. You have 2 7. T4, you add 7 again, you have 3 7. T5, 7 again, 4 7. Now, Mark, talk of the nth term here.
The nth term. Now, look at the pattern, guys. This is so exciting. If you check the slide, notice you've got T3. Okay, look at this. You've got T3 here, and over there it goes to 2. In the brackets, 4. And there's a 3. It's 1 less. 5 and a 4. So in other words, if that's an n, that's an n minus 1. This is called your general term. Now we can simplify it. If you multiply out times the brackets, we get that there, and we have a general term. It's called the general or nth term, and it's used to determine any specific term of the pattern. So, for example, if you wanted the fourth term, which we know is 32. This is important, guys. We know it's 32, but now watch what the rule does. If you say T4 and you sub in 4, 7 times 4 is 28 plus 4 is 32. You can now work out the thousandth term or the millionth term, 7,004, which is rather cool. I don't know about you, Nelson. I really think that general terms are really wonderful.
Very important, Mark.
Okay, now look at this as well. What you can discover is that that's the first term, the constant difference, and what is very nice about this is we've got Tn as a plus n minus 1d is another rule that we can use where a is the first term and d is the constant difference. Yep. Okay, this is so important. Nelson, do you want to talk exponentials quickly?
Exponential, guys. Right. Same thing. We try to describe this. Each consecutive term is obtained by multiplying by 2. The ratio of the second to the first term is therefore 2. The ratio of the third to the second term is 2, and so forth. Right. Okay. If we take T2 divided by T1, we get 22 over 11, which is 2. This is what you call the ratio. And we take T3 divided by T2, we get 2. And T4 divided by T3 is still 2. All these guys are called, this is what you call constant ratio.
And the constant ratio is referred to as little r. Okay, the first term is a, as you know.
Yeah.
Okay, so let's see if we carry on, Nelson. What can we discover? We've got...
Now, T1 is 11.
Look at that.
T2 is 11 times 2. We're multiplying now.
Correct.
T3 is 11 times 2 times another 2. we've got 11 times 2 squared. T4, same pattern, times 2, and then we have 11 times 2 to 3, and T5 is 11 times 2 to 4. Right, now, this is the general rule for this specific sequence. Okay, Tn is 11 times 2 to n minus 1. But how do we use this?
That's, if we look at this, the 11 is going to be the first term, and 2 is the constant ratio. Now, a lovely rule that we've got, guys, is Tn is a r to the n minus 1. A being the first term. Have a look there. It's the first term for A, and the r is the constant ratio which we use. And then, of course, we can use that to generate the sixth term. Okay, plug in 6 minus 1 gives you that. And very important to remember, the 2 is the constant ratio, A is the first term, and then what we've got is we can then say T6 is that. And we can do so also if we've got the 10th term. That's exponential form, work it out, and we get that. Now, guys, stay with us. Don't go away. In the next lesson, we're going to carry on with wonderful, beautiful number patterns. Don't go away.
Cheers.